Good morning, class. Today we're going to talk about applications of right triangle trigonometry. These are word problems that use our sine, cosine, and tangent, and even special right triangles to help figure out answers. A lot of times they'll use references to angle of elevation. That's right here, from the ground up to a line of sight. Also, they'll talk about angle of depression from that horizontal down. One thing to remember is that because of parallel lines, we know that this angle of elevation and angle of depression, because of alternate interior angles, are going to be congruent. So we can think about that. Oops. We could think about that over here as well. Okay, so let's try to do this problem over here. A fire department's longest ladder is 110 feet long, and the safety regulations state that they can use it for rescues up to 100 feet off the ground. What's the maximum safe angle of elevation for the rescue ladder? So what we first do is draw a picture. So this is the building or the rescue. This is the ladder, and this is what we're trying to find out. So opposite over a hypotenuse. So we're going to use the sine, but in this case we don't know what the angle is. So to get x by itself, we take the inverse sine of both sides, so that's where we get this. And then on our calculator, we press the button. And so if we're rounding this, let's round this to the nearest integer. We would say 65 feet. Okay. So next we go, a lighthouse operator is at a point. So we have a lighthouse, 25 meters above sea level. Angle of depression is going to be 10 degrees. And they want us to find how far the boat is. From the base of the lighthouse. Okay, so again, we'll set this up. If this is 10, that means this is 10. Parallel lines implies alternate interior angles are congruent. So then we go with the tangent of 10 degrees equals 25 opposite over x. I would multiply by x and divide by the tangent of 10 degrees. And so you would get x equals and in this problem I believe they said round to the nearest 10 meters, so that would be 140 meters. Okay, so next we'll go to this problem. So in this we have a tent, center pole, 6.25 feet. We don't know this, and we know the angle is 50 degrees. Okay, so again we're going to use, in this case we'll use the tangent of 50 degrees equals 6.25 over x. X is going to equal 6.25 divided by the tangent of 50 degrees. And then x is going to equal 5.24. But remember, that's only half of this. So then we have to multiply that by 2. And so that's where our answer of 10.49 feet would come into play. Last one, and this is sort of a very famous style problem. We have a tree and a shadow. So this is the tree, shadow of 21 meters, and the sun is 51 degrees. So then we look at this. This is tangent. 51 degrees equals x over 21. So So x is going to equal 21 times the tangent of 51. So x equals 25.393, sorry, and that would be meters. Last example here, flying a kite. So we have the kite, string, 80 meters. That is 40 degrees. How high is the kite off the ground? Opposite hypotenuse, so we're going to use sine of 40 degrees equals x over 80. So we'll do sine of 40 degrees times 80. So we get x equals 51.4. And let's round to the nearest meter, so our answer would be 51 meters. Have a great day.